Hello friends, in today's question, a uniform circular disc has radius r and mass m. A particle of also mass m is fixed at a point A on the edge of the disc as shown in figure. The disc can rotate freely about a horizontal chord PQ that is at a distance r by 4 from the center C of the disc. The line AC is perpendicular to PQ. Initially, the disc is held vertical with point A at its highest position. It is then allowed to fall so that it starts rotation about PQ. Find the linear speed of particle as it reaches its lowest position. So this is a circular disc and we have chord PQ about which it will rotate, and this chord PQ is at a distance of r by 4 from the center, and particle A is at a distance of r from the center. Therefore, let us first of all draw the figure. So we have a chord and we have a disc, and to disc we have a chord PQ, and this is our center C. Center C is r by 4. We have particle A which is at the highest position, and we have this chord PQ, and about this it is going to rotate. So if it after rotation it will be coming like this. So now point C will be here and its distance from the chord PQ will be r by 4, and we have a point A which will be r distance, and this point A is fixed, mass A is fixed at point A. So we can say it is rotating in this direction, let us suppose with angular velocity of omega. So we can say this is our initial position, and this is our final position. And here this disc is rotating about the chord PQ. Okay. So for the initial position we are going to find out energy, and for the final position we are going to find out their energy, and then we are going to proceed further. So let us first of all find out initial potential energy, because it is stationary initially, so there won't be any kinetic energy. So you can say here initial potential energy. Initial potential energy. So under this condition, disc is held vertical with particle A at the highest point, with particle A at highest point, and the initial kinetic energy of the system means disc as well as particle is equal to 0. The system and system means disc plus particle is at rest. So therefore we can say kinetic energy initial is equal to 0. So therefore the total kinetic energy, or we can say total initial energy rather, total initial energy will be total initial potential energy. Total initial potential energy due to height of the point particle A and the disk, center of the disk from the chord PQ. So total initial potential energy will be due to height of particle A and the disk center of mass, from PQ. So in this case, everything will be in the reference to PQ. PQ will be act as a base, and here the potential energy we can assume will be equal to 0, and with the reference to it, the potential energy on the top side will be positive and the bottom side will be equal to negative. So the question itself, in the figure itself rather, it is given that the height of center of mass with respect to PQ is P by 4. Height of center of mass of disk with respect to PQ, chord PQ, is equal to R by 4, and height of point A is R plus R by 4 with respect to chord PQ. Height of point A with respect to chord PQ will be equal to R plus R by 4, which comes as 5R by 4. So we already found out what will be the distance of the chord as well as, of the center of mass as well as point A with respect to chord A. Therefore, now we can find out the total energy. So we can say total initial energy is equal to initial potential energy because of the disk and initial potential energy of the particle, their summation. You can say initial potential energy of the disk plus initial potential energy of the particle. So we can say U initial is equal to, we have mg R by 4 plus mg 5R by 4, and this comes as 3 by 2 mgr. So this is our initial potential energy or total energy when your disk is above the, without a rotation basically. It is above on the top side of the chord PQ. Now we find out the final potential energy. So final potential energy under this condition, this point A is at its lowest position and the center of mass as well as this point A is on the lower side of the chord PQ. So final potential energy, you can say that is at the lowest point. At the lowest point, both disk and particle A have fallen from the height. Have fallen from the height. So now the height of center of mass, height of center of mass of disk will be equal to, now the center of mass is distance r by 4 below PQ. You can say center of mass is at a distance r by 4 below PQ. So from here we can write that height of center of mass with respect to PQ will be now equal to minus r upon 4. Now we come to height of the point A. Height of point A. Now point A is at a distance of minus r and minus r by 4 with respect to chord PQ. Height of particle A with respect to chord PQ will be equal to minus r by 4, and this becomes minus 5r upon 4. So therefore the total final potential energy will be equal to minus mgr upon 4 minus mg5 upon 4, and this comes as minus 3 by 2 mgr, or we can write it as potential energy final will be equal to minus 3 by 2 mgr. So we found out potential energy initial as well as potential energy final. Next, there will be also, you can see, as it is going to rotate, so there will be some form of kinetic energy also. So we can use the conservation of energy. We can write that U initial will be equal to U final, and U final will be consisting of two parts. One will be the kinetic energy final and potential energy final. So this can be written as kinetic energy final plus potential energy final, and U initial is our 3 mg r by 2. So we write this as kinetic energy final, and minus this will be here our 3 by 2 mgr. So from here we can find out that our kinetic energy final will be equal to, this becomes 3 by 2 plus 3 by 2 mgr, and this is equal to 3 mgr. Let this be question number 1. Now we are going to find out, because this kinetic final energy is also being generated by the rotational as the disk rotates, okay, and along with the disk the particle is also moving. We can say that our final kinetic energy which I have already written as Ke final So this K total kinetic energy final is at the lowest point of the after rotation. So you can say total kinetic energy final at lowest point. Okay. Here lowest point means after rotation, and it will be consisting of two parts. First part will be rotational kinetic energy of the disk with respect to chord PQ. Rotational kinetic energy of disk about chord PQ plus translational kinetic energy of particle A. Translational kinetic energy of particle A. So now let us find out the first part, that is a rotational kinetic energy of disk about chord PQ. Rotational kinetic energy of disk about chord PQ. And that will be given, let us say that is our I rotation of disk about chord PQ is equal to half moment of inertia of disk about chord PQ and angular velocity square. So we have to find out the moment of inertia of the disk about chord PQ. So first of all, for that we are going to use the theorem of parallel axis, and we know the formula for the moment of inertia of the disk about its diameter. Then using the parallel axis we are going to find out the moment of inertia of the disk about chord PQ. This I disk PQ, it is moment of inertia of disk about chord PQ. So this is our now disk, and this is our PQ chord, and this is our diameter. Let us suppose that is AB, and we are going to find out, and the distance between these two parallel axes is r by 4. So first of all we find out moment of inertia of disk about diameter AB. Moment of inertia, and this is center C. Moment of inertia of disk about its diameter AB will be equal to, let us write it as I disk about AB will be equal to 1 by 4 and mr square, where r is the radius and m is the mass. Now we use theorem of parallel axis and shift the moment of inertia to chord PQ. Using theorem of parallel axis, moment of inertia of disk about chord PQ, which is given as I disk PQ, will be equal to I disk about diameter AB plus mass and distance between the two parallel axes and their square. So we can write that our I disk about chord PQ will be equal to 1 by 4 mr square plus 1 upon 16 mr square, and this comes as 5 upon 16 mr square. So we found out the moment of inertia of the disk about the axis of rotation, that is PQ. So therefore we can write that rotational kinetic energy of the disk about PQ, rotational kinetic energy of disk about PQ will be equal to, this will be our formula we already know, is half multiply with the moment of inertia 5 upon 16 mr square and omega square. So this comes as 5 upon 32 mr square and omega square. Now we are going to find out the translational kinetic energy of particle A. Translational kinetic energy of particle A. So we say let its linear speed is VA. Okay. Say that particle A moves with a linear speed which is given as VA, and obviously its angular speed will be also equal to omega because it is fixed with the disk, and disk is rotating with the angular speed of omega. So you can say for angular speed of omega, the linear speed VA will be equal to the distance between the axis of rotation and particle A and multiply by omega, that is r plus r by 4 to omega, which comes as 5r by 4 into omega. So this will be its linear speed in terms of the angular velocity, because particle A is fixed and it is rotating about the axis PQ, and the distance between, this is r, between the axis of rotation and particle A is r plus r by 4. So therefore its angular velocity and the linear velocity will be related by this relationship 5r upon 4 into omega. So finally we almost got all the parameters via metrics, and then we are going to find out our K. And now we find out our kinetic energy of the particle, which will be equal to half m VA square. So this becomes half m VA, we already know, is 5r upon 4 into omega and its square. And this comes as kinetic energy of the particle will be equal to 25 upon 32, and we have here m r square and omega square. So now total final kinetic energy will be kinetic energy of the particle plus the rotational energy of the disk. Therefore kinetic energy final is equal to 5 upon 32 m r square omega square plus 25 upon 32 m r square omega square. So this can be written as 30 upon 32 mr square omega square, and we can cancel it. This will be coming as 15 and this will be going as 16. So this will be equal to 15 upon 16 mr square and omega square. So we found out that kinetic energy final is 15 upon 16 mr square omega square, and we also found out, we already know rather, that we calculated in equation 1 that kinetic energy final is 3 mgr. So let this be equation number 2. So comparing equation 1 and 2, so here we can write, but kinetic energy final is equal to 3 mgr, which is nothing but our equation 1. Therefore, comparing equation 1 and equation 2, we get 3 mgr is equal to 15 upon 16, we have m r square omega square. M cancel with m, r goes with this r, and this cancel by 5. Therefore, we get that our angular velocity omega square will be equal to 16g upon 5r, or we can say omega is equal to square root of 16 g upon 5r. And we already know relationship between the linear velocity va and angular velocity omega. Therefore, the linear speed of particle A, which is given as Va is equal to 5r upon 4 multiplied by omega, and this becomes as 5r upon 4 square root of 16g upon 5r. Now to a simple calculation, this becomes 25 r square multiplied by 16g divided by 5r, and sorry, I missed 16 here, 16 because of 4. So this r cancels squares, 16 goes with 16 and this goes by 5. So we can say that our Va will be equal to square root of 5gr. So this is the linear speed of the particle at its lowest position. This is the linear speed of particle at its lowest position. So this completes the question. Thank you.